Welcome to Aston Means Business, a podcast from Aston Business School. My name's Steve Dyson, and I'm a journalist who's interviewing some of the UK's top business academics here at Aston. This podcast has been going since October 2019, and there are now more than 30 previous episodes that you can find and listen to simply by Googling Aston Means Business. Today's episode is all about 3D printing and how businesses are using this technology to successfully disrupt traditional manufacturing. We'll be interviewing an expert in 3D printing technology later, but first, I want to talk to Dr. Ahmad Beltagui, a lecturer in Operations and Information Management in the Advanced Services Group at Aston Business School. Hello to you, Ahmad.
Hi, Steve. Thanks for having me. It's great to be here.
No problems. Ahmad, tell me a little bit about who you are and what brought you to Aston.
Yeah, so as you said, I am in the Operations and Information Management department at Aston Business School, and I work with the Advanced Services Group. And my research is about some of those topics. So I focus on how businesses innovate by using a combination of design, business model innovation, and digital technologies, including 3D printing.
3D printing is what the subject today is all about, of course. We've all heard of it, but can you tell us a little bit more about it and the range out there from the most simple to the more complex technology?
Yep, so really that term is used to cover a large range of various different processes and different technologies. There are two things they all have in common. So the first thing is that they build things in layers additively. Rather than cutting material away, you add layer on layer. The second thing is that they build directly from a computer model. So you don't need tools, you don't need molds. You go directly from your screen digitally to your production. The simplest of those is what's called fused deposition modeling, FDM, and that melts bits of plastic out of a nozzle. Those can be quite cheap, so you can get a machine for as little as a couple of £100. It has limited use, so it's very good for making little models. You can use it for making toys for your children, as I do. But then you can go all the way up to some really amazing stuff that uses lasers to melt metal powders. You can work with exotic materials like titanium. And those are obviously a lot more expensive. So there's a huge range of different technologies.
Ahmed, I wonder if you can give me a few examples of where this 3D printing, or what I know is commonly known as additive manufacturing, where it's made a big difference in society.
Yep. So originally it was used for rapid prototyping, and you still hear that term used. So very useful for making cheap and quick models that let your design team or your customers be able to see and to touch something before you start producing it. And that's really helpful because you don't just need to look at a picture on the screen or on a piece of paper. You can actually see what the thing will look like. What's been really exciting in the last few years is that we've gone from prototypes they look like the real thing, but they're not functional, to producing end-use parts. And there's a lot more of that now. So, for example, if you were to go and get a hearing aid or a dental crown, these days there's a good chance that it will be 3D printed. A dentist might have a machine that can produce the crown to fit your teeth while you wait. I think a lot of the main applications are really in medical and aerospace industries. So in aerospace, they make complex shapes that can be produced in a single part instead of assembling it from many different parts coming from many different suppliers. So that makes your supply chain less complex. Perhaps you can use one supplier instead of 20. And you can reduce the weight, which is very important in an aeroplane. It means you use a lot less fuel. In medical applications, things like hip replacements can be custom made for a specific patient. And there's lots of other medical applications.
Yes, I can see some of those end products and also some ways in which it helps the manufacturing process. What other benefits has 3D printing brought to manufacturers?
So I would say there are four main things. The first one is that compared to traditional manufacturing methods, you can produce shapes that are harder to produce, um, such as those complex shapes and lightweight structures that I mentioned. Um, you can produce things in very small volumes. So normally with traditional methods, we think about mass production. To make it work, you need to have a large volume of things that all look the same. With 3D printing, with additive manufacturing, you can make every part you produce customized. So you can make something that's better suited to a specific need or a specific customer. The third thing is that you can innovate faster. You can produce lots of prototypes. You can iterate a product very quickly, again, because you can produce one offs or small volumes. And the fourth one, I think, is being able to produce things nearer to where they're required. So you don't have to produce in a factory in one place and transport somewhere else. You can distribute that production a bit more.
I understand there's been almost an acceleration in some of those benefits since the pandemic. Can you go into some detail on what benefits that's seen since COVID-19?
Yeah, I think what we've seen really is the flexibility and that distributed production. So, for example, when there was a sudden unexpected demand for things like ventilators and face visors, what people did was create designs or share designs so that parts could be produced anywhere in the world. So you could be producing a cheap face visor and delivering that to your local hospital if you have a 3D printer at home. So what we've seen is it's been possible for individuals and companies to respond very, very quickly to demand that was unexpected.
Stay with us, Ahmad, as we hear now from your fellow Aston academic and 3D printing expert, Dr. Mark Prince. I spoke to Mark earlier on and asked him how he got involved in 3D printing in the first place and how things have developed in recent years, in particular with some of the products he's been making for the NHS. Mark, give our listeners a summary of your background and how you got involved in the sector.
I'm a senior lecturer in mechanical engineering at Aston, and I did my PhD some time ago. And during that process, I was interested in new manufacturing technologies, particularly microfabrication. But at the same time, we started to look at microfabrication of very small channels. It's a technology known as microelectromechanical systems. And at the time, we purchased one of the best 3D printers you could get, which was a stereolithography apparatus that printed really tiny things. Obviously, that was some time ago. The technology has moved on. And as a result, my interest has moved on as well in terms of the materials we can use and the processes we can use. And it was through that knowledge that I managed to engage with a couple of consultant surgeons within the West Midlands who were looking to solve a problem. And I was able to use my additive manufacturing knowledge to help them out. And the result of that was we developed a new technology and we spun a company out of it.
Tell me a little bit more about Endoscope Eye. When did you launch it? What exactly does it do? And what's its staffing and turnover?
So we started the company in 2012, and it was to solve a very simple problem. Now, two of the founding members are consultant surgeons working within the West Midlands, both ENT surgeons with an interest in endoscopy. And the other complement are myself as an engineer and a software engineer to make sure what we do all works. And the idea was simple. Can we get medical endoscopic images of the ears and throat using a smartphone? And we came up with a technique to do that made the most of the high quality optics we had available to us. And it's grown ever since. Now, we're growing it quite gradually because we're trying to keep our feet in our core specialisms. So we're keen to pay back in healthcare, and we're keen to pay back in education, but we also want to move things forward. And the company having started just under 10 years ago, we're now enjoying a turnover around about £200,000 a year, and we're selling our products throughout the globe.
Mark, how have Endoscope Eye's products and services developed with the help of 3D printing during the pandemic?
We found the pandemic very helpful in terms of providing inspiration for our latest product, but also for allowing us and inviting us to think differently about how we could achieve it. And additive manufacture was fundamental to the way we managed to achieve it. Traditionally, I'd have used large, expensive additive manufacture equipment in order to prototype the systems and prototype the new products. That wasn't a possibility. The majority of the university was closed down. The majority of our facilities were closed down. And so we had to look at other technologies that were safe to use in the home, that I could iterate the design with, rapidly make changes, and prototype and test, all without breaking the regular requirements of lockdown. So by redesigning our new product over and over again, getting it posted over to the hospitals for testing with, and then making the design changes and producing and developing all at home, if it wasn't for additive manufacture, we wouldn't have that product.
Additive manufacturing is the technical term for 3D printing, isn't it?
That's correct, yes.
And just explain to us in terms of how, what machines you use and what type of product you have actually produced for the NHS.
Okay, so the product we were making was a valve, and the idea behind it is a single-use valve that can fit within a mask. So one of the problems we were facing within ENT, or ear, nose and throat, was the requirement for patients to wear masks in order to contain the virus and prevent it communicating between patient and clinician and patient. When we're looking at diseases or concerns of the throat and nose, we often stick an endoscope up the nose and down the throat and take a look at what's going on. But of course, you can't do that through a mask. Some people were looking at putting holes in masks. Of course, that kind of defeats the object of there being a mask. So what one of our founders, Mr. Ajith George, suggested was perhaps we could put a valve in the mask that allowed an endoscope to pass through it and allow the procedure to go ahead without breaking containment and without subjecting the environment to contamination. So it's relatively small plastic and rubber type materials. Rubber type material for the valve, and rigid plastic for the housing to hold it securely to the mask. And these were all produced using an FDM process. So that's the typical toothpaste type molten plastic process that most people have become familiar with now. And these were done using industrial grade machines, but not out the grasp of the majority of SMEs. I mean, the principal machine I used was a FlashForge Creator 3, which is actually just behind me now, and that was £2,500. What that has allowed the NHS to do is any ENT clinic was able to fit it to a mask, put the mask on the patient, carry on with a nasendoscopy procedure as they previously would have without all of the concerns of the pandemic. The device is small, so I could produce it quickly. I could produce it rapidly. I could iterate the design very quickly. And because I could make the change and quickly test it in the home, I was able to iterate the design and get to almost a pre-production version. We started, I think it was the middle of March 2020. We had the design largely finished by the middle of June. And that was only as a result of delays of waiting for clinical tests. After that, I was able to iterate the design further for injection molding. And then by the time the tooling was finished, that was around about late August, and we were ready for then final testing and certification ready for free supply to the NHS in November.
It's an amazing example. How has that shown you what's next for the company and for 3D printing in general?
It has allowed us to see, and of course, it encouraged me as someone who works in additive manufacture a lot. It allowed me or invited me to look at it from a lot of different perspectives. Naturally, I know from the literature all the different ways that the materials behave. I know the vast array of materials that are available in terms of their properties and the attributes that the processes bring. But also, what it allowed me to do is gain an insight and invited me to reflect on how additive could play a bigger role in our core business. So, for example, our endoscope adapter technology, which connects the smartphone to the endoscope and allows this digital imaging to happen, that was conventionally injection molded because we needed precision, we needed repeatability, and we wanted we wanted it to be right every time. When we started to look at the economics as a result of the work we did with the snap device or the mask device, it invited us to look at how we could benefit by looking differently at the production of our adapters. And we've now taken a point where we've shifted entirely from injection molding, and now 75% of our products are manufactured through additive alone.
Wow. And of course, at Aston, you've got a facility which is available for SMEs, haven't you?
Absolutely, yes. So I'm a lecturer. I'm a design engineer in Endoscope Eye, but I'm also the co-director of the Advanced Prototyping Facility at Aston. And it is a facility where we've taken all of our capable facilities, all of our high-end industrial-grade machines, as well as some of the lower entry-level machines. And we've taken on a couple of experts that will help local industry to understand how additive can help, how you can approach taking on additive to your processes, the costs involved and the things to watch out for, the design skills you might need in order to leverage additive manufacture in your forward journey.
Dr. Mark Prince, a senior lecturer at Aston University in the Mechanical, Biomedical Engineering and Design department, and also the design engineer at Endoscope Eye Limited. Many thanks for joining us on Aston Means Business.
Thanks so much, Steve.
Hello again, Ahmad. Are you still with me?
Yep, still here.
That was fascinating to find out from Dr. Mark Prince about how Endoscope Eye has been using specialist 3D printing to swiftly help the NHS during the pandemic. But overall, the technology has until now not revolutionised manufacturing. What have been some of the stumbling blocks, and are they being overcome?
Yes, I think people have been talking for at least 30 years about a 3D printing revolution, but I think it's been more of a slow evolution. I would say I don't think that 3D printing has or ever will replace everything else. But what we're starting to see now is that it's become accepted that additive manufacturing is part of the set of tools that a manufacturer can use. So it fits alongside other methods. What's happened over the years, the technology has matured. By that, I mean that the machines have become more reliable and there's a better level of quality in a range of materials, as well as the cost coming down. Another thing is that perhaps the applications weren't really clear before, but we've seen the pandemic, I think, accelerate some of that. We've seen some of the value of being able to produce things quickly, respond to demand, produce in a distributed way. To keep that going, I think what we need is some of the skills that Mark mentioned, particularly things like being able to design and 3D model products. As well as that, I think engineers understand what the technology can do. I think we need managers, we need investors to be able to understand what is possible and what is realistic.
I wanted to pick up on the cost side of things, Ahmed, because 3D printing technology can be hugely expensive, With some of those top-end machines costing hundreds of thousands of pounds, how can SMEs make sure they still get some of the benefits despite those costs?
Well, I think the beauty of the digital aspect is that you don't have to make that investment upfront. It's possible to be able to send digital files and pay for one part to be produced. So I've seen companies that have either paid for someone to produce some parts for them and then bought the equipment when they find that they do use it enough. Or in some cases, they maybe invest in a lower end machine. They spend maybe £1,000 on a decent quality desktop machine and find lots of uses for it. In other cases, there's an example of General Electric who were getting suppliers to produce prototypes for a fuel nozzle on an aeroplane engine. They got so much benefit out of the additive manufacturing of that they not only bought the supplier, they started their own additive manufacturing business, GE Additive.
It's great to hear some of those examples of how it's working in manufacturing. There are, of course, some downsides to 3D printing, especially with legal and ethical risks in mind, aren't there?
Yeah, I think it might be helpful to think of this like what happened with music when we went from physical copies to digital file sharing. People and companies aren't always ready for those kind of changes. An example is that at the beginning of the pandemic, someone in Italy found that they could produce some spare parts to keep the ventilators in their local hospital running. That was a good news story shared on social media. But then a few days later, the news was that the manufacturer of those ventilators was considering whether or not it should take legal action. So it's a different way of producing things. I think the great thing about 3D printing is anyone can produce anything they want. That's also the biggest risk. There's no control over what people produce. You could produce dangerous things like guns, or how safely they produce it. You could produce dangerous things like guns that will hurt you because they're not made to quality standards that would make them work safely. And I think that's the concern with things that are being used in hospitals. Mark talked about the rigorous process and the testing and the certification that they had to go through. That's not something that everyone will do.
On the positive side, Ahmad, how much is 3D printing worth to the economy, and what could it be worth in the next 5 years?
So the estimates for the industry globally are around $12 billion. And that's grown an awful lot in the last 10 years or so. And now it's evenly split between 3D printing machines and services related to 3D printing. The more that we see additive manufacturing alongside other manufacturing technologies, I think it will be a lot more difficult to separate the value of 3D printing. But I believe there's a lot of potential growth, and particularly in the services that make use of 3D printing.
What would you say is next in the future of 3D printing, Ahmed? And why is the sector potentially so interesting and important to students at Aston University?
Well, I think the only limit really is your imagination and your ability to create a digital model of what you've imagined. So I think that managers and students really need to have a good understanding of what is possible, what 3D printing can do, alongside all of the other digital technologies and traditional manufacturing technologies that are out there.
Dr. Ahmad Beltagui, Lecturer in Operations and Information Management in the Advanced Services Group at Aston Business School. Many thanks for joining Aston Means Business today.
It's been a pleasure. Thank you very much.
Thanks for listening to Aston Means Business, an original podcast series for Aston University. Remember, if you enjoyed today's episode, you can find earlier episodes by simply Googling Aston Means Business. We've also got a podcast series called Society Matters. That interviews top academics at Aston's School of Social Sciences and Humanities about current issues and concepts which shape our world and the way that people live. You can find those episodes simply by Googling Society Matters Aston. And if you're interested in all things business, economics and politics, why not check out what Aston University has to offer at www.aston.ac.uk/courses. Meanwhile, we'll be back soon with more interviews from some of the UK's top business academics here at Aston. Aston means business. Thanks for listening.